test. One is for a single mean, right? That is when we have to see for the some specified value. We have to check whether the population mean is equal to some specified value. At that time, we use the one sample t-test. Then there are two sample t-test. One is dependent and one is independent sample t-test. So dependent sample test we use generally when our groups are correlated. For example, like scores before training and after training, like this. And independent sample t-test means when we have the independent group, right? Yeah, like example we have taken in last lecture, that IQ of male and IQ of female. If we want to check whether it is same or not, that we have considered last time. Now, also we have seen ANOVA also last time. Now we will see some non-parametric test in this session. Before that, we will start with the proportion test, isn't it? As these are all the management and commerce students, I think they are having the such type of situations frequently they will come across, isn't it? Because many times your data is like in categorical or in Likert scale. So at that time, this test will be useful to you. So let's start with the single proportion test. From the name itself, it is clear that we are having only one group of observations, right? Then it is a proportion test, means if we want to check whether, since it is a single group test, so the hypothesis is the proportion of some characteristic is equal to some specified value, say P0, against if it is a two-tailed test, it will be P not equal to P0. If it is a one-tailed test, then we have the alternative hypothesis P less than P0 or P greater than P0, isn't it? P0 is the specified proportion. It will be more clear to you from examples. So let's see some examples. So here are the examples. The first one is some manufacturer claim that at least 95% of the steel pipes which he supplied to the factory conform to the specifications, isn't it? So I will be happy if you interact or respond the question. So what is the P0 value here from this first example? Can you tell me what is the value of P0? Anyone? In chat box you can reply, or you can unmute yourself and reply. There is no problem. I will come to know that you understand only if you reply. And I will like to have the interactive sessions. 0.5. Okay. All right. Somebody has answered that P is equal to 0.5. But see here, what we are testing is, what is the claim of the manufacturer is that at least 95%, right? Percent means proportion of good pipes, isn't it? Conform to the specification means whatever the specifications are there, according to that pipes are there. So his claim is that whatever the pipes he is supplying, 95% of the pipes are according to the whatever the specifications are there, isn't it? So this proportion means this 95%. So what we have to test here is P is equal to 0.95, right? So in this case, our H0 will be P is equal to 0.95. If you want to test, it will be against the alternative hypothesis P not equal to 0.95. Okay. I hope now it is clear to you how we formulate the hypothesis or construct the hypothesis. Now let's see second example. Maybe it will be more appealing to you because your whatever studies are there, I think they are related to something social sciences, isn't it? So a social worker want to check whether in a certain village there are 30% smokers. So in this case, what will be the hypothesis? Yes, what is the hypothesis in this case?
मैम एक बार फॉर्मूला बताओ ना मैम.
Okay. So for that, let's see the previous slide. This is the simple hypothesis that we have to check, isn't it? P is equal to P0 against P not equal to P0. In this case, what is P? I will repeat it again. What is P is the proportion, right? Proportion of whatever you want. Suppose it is you are testing whether male and female proportion is same in India or not, isn't it? In that case, P will be 0.5 because you are testing that both are equally distributed, isn't it? So in that case, your P will be 0.5. Proportion means whatever is the number of that characteristic divided by total number of your population, whatever is there or sample is there. Okay, so now I hope that it is clear to you and you will give me the answers, right? So in this case, when somebody wants to check whether the proportion of smokers is 30%, means what is your H naught? Yes, what is H naught? Do you understood? Are you there?
Yes ma'am.
Okay. So,
P is equal to 30%.
30% means if we want to write in fraction, it will be 0.3. So it will be 0.3, right? Then next example is an employer claims that the female employees in his company are more than 40%. See now, the employer wants,
P is more than 0.4.
right, and this is very good, Sandhya, and this is the alternate hypothesis, isn't it? Research hypothesis. When we have to test like this, some greater than, less than type, then this is our research hypothesis or alternate hypothesis, right? So what he wants to test is more than 40%, means H1 is P more than, that is greater than 0.4, right? And the null hypothesis will be P is equal to 0.4. Now I think it is clear to you what we are testing, because it is very important how your hypothesis you are constructing. All the test statistic depends on how you formulate your hypothesis, right? That's why you should understand first how will be your hypothesis, and then comes the part of the test statistic. Okay, right? Now now you understand how or which type of examples or case studies you can study using this single proportion test. Okay, now see here, what are the requirements of this test? We will see that first. A dichotomous response variable means your question should answer like yes or no. Only two categories should be there, isn't it? In any case, when you have only two characteristic or two answers to your response, yes, no, like that, then you can, or success failure, In that cases, you can use this test. Okay, it can be nominal or ordinal. I think all the types of scales already you have one lecture on that. And here P is the probability of success. Okay, like in smokers example, smoker is a success. If a person is a smoker, then we will calculate it as a probability for success or the number of successes. Okay, and P remains constant from trial to trial. These are the assumptions. Now the test statistic. The test statistic is Z here, and it is given as P minus P0 upon square root of P0, 1 minus P0 and divided by N. Okay. Here P is the number of successes in independent trials. Okay, whatever the sample you have collected, in that how many successes are there, that we will consider as this X. N is your total sample size. Okay, means for example, if you are, which examples we have taken. Okay, so suppose female employees, how many are there that somebody is considering. Then suppose he is taking sample of every department from the company. So in department, suppose quality assurance, so there are total, how many total employees are there, and out of that how many female are there, right? That will how we will compute this value of P. Then P0 is, his claim is that 40% employees are there, so it will be 0.4, right? Then 0.4 into 1 minus 0.4 and divided by N is the total number of employees in that company. Like this, we will compute this formula. Okay, we will take one example also on that. Then the decision criteria. Again, it is important whether we will accept or reject our hypothesis. So for that, we have to reject the null hypothesis if mod Z, isn't it? Whatever is the value of Z is there, it can be negative or positive. Whatever it is, either positive or negative, we will consider mod Z means only positive value. Okay. If it is greater than equal to Z, means this is the table value of Z at alpha by 2. Then we have to reject H0, right? This is for two-tailed test. Okay, from here you can see that it is for two-tailed test. If your hypothesis is like P less than P0 alternative hypothesis, then the decision will be taken as if Z is less than equal to minus Z alpha, then you have to reject your H0. Otherwise, accept H0. Okay. And in the same case, again, sorry, you have to reject H0 if your hypothesis is P greater than 0, if Z is greater than Z alpha plus Z alpha, right? In this way, the decision criteria will be. All right. Just a minute. I have an important call. I will take only 1 minute. Right. So let's take one actual example. A ticket checker claims that 10% of the passengers are traveling without ticket in one day, right? To verify his claim on a certain day, 1000 people are checked randomly, right? Out of which 80 were found without ticket. Was his claim right? And we have to use 5% level of significance. Now, let's read the example again and let's understand it, how it is. A ticket checker claims that 10% of the passengers are traveling without ticket in a one day, right? So what is this 10%? Anybody?
Right.
What is this 10%? Yes, sir.
100.
Means we have to check. What we have to check? What is his claim? That we have to verify. So this is value of P0, specified proportion, that we have to check the claim. This is 0.1. Some ticket checker or TC is saying that 10% of the passengers are traveling without ticket, isn't it? It is his claim, and that we want to verify. So obviously our P is equal to P0. Our hypothesis will be P is equal to P0, that is 0.1, 10% of the passengers only. Now what somebody will do, if want to check, really has to go to suppose railway station and see and check the whatever are there randomly, isn't it? It is the general procedure by the TCs. They do like that only. Randomly tell somebody to show the tickets. Like that, already the study was completed and 1,000 people are checked randomly, out of which 80 were found without ticket, right? Now, how we will calculate our value of P is, see, this is value of P0, that is 0.1, that is the claim that we want to check. Now, to find out the value of P, we have to consider 1,000 people, okay? In that, 80 are found without ticket. Now, in our case, this is the success, that the person is without ticket, means that we want to test. So this is a success for us. Okay. So P will be calculated as 80 divided by 1,000. Okay. Like this, we will find, once you have the value of P and P0, it is very easy to find out or complete the test, isn't it? So here I have given the hypothesis that we have to check. It is P is equal to 0.0, that is 0.1 against P not equal to P0. That is a two-tailed test. Okay. Now, in this case, the test statistic is, already I have told you, this is x upon n, that is 80 by 1,000, that is 0.080. Okay. Now the test statistic is P minus P0. P is 0.08, what we have calculated. Then P0 is the specified value, that is 0.1, divided by P0 into 1 minus P0. P0 is 0.1 into 1 minus P0 and divided by total number of person he had checked is 1,000. So here divide by 1,000. So if you calculate this, since 0.08 is less than 0.1, it is going to be negative. That is 0.10819. Right? Now, I have already told you how to take the decision. The value of Z alpha by 2. Since we have considered alpha as 0.5, this alpha by 2 will become 0.025 and its stable value. If you just see in the Google and type there Z table, you will get the table. And in that table, if you find it, I think I have also put it in the next slide. It is 1.96. Now, we have to take the decision according to if mod Z is less than Z alpha by 2. Yes. See here, mod Z means positive of this, that is 2.10, and it is greater than 1.96. So we have to accept our hypothesis. Okay. So that is how, I think it is wrongly written as less than, but it should be, yes, mod Z
More
is
than.
greater than, it should be there, Z alpha by 2. And so we have to reject H naught. Right? So in this way, we can test the single proportion test. Now, suppose you, previously we have some claim is there. Now we have two populations and we have to check the proportion of that population, some characteristics of that population, whether it is same or not, right? Like population is suppose there population of human beings, then we have to check whether number of male is equal to number of females, isn't it? Proportion of male is equal to proportion of female. Then we can go for this two population proportion test. So here we have our H naught will be constructed as or formulated as P1 is equal to P2 against H1, P1 not equal to P2. If you are interested in saying whether it is less than or greater than, then your alternative hypothesis will be formulated according to that. That is H0, you can keep it here, P1 is equal to P2 also, there is no problem, against P1 less than P2. Or H0 is P1 is equal to P2 against H1, P1 is greater than P2. Like this test will be. Again, we will take some examples so that it will be clear to you. So here are some examples of two population proportion test. Female proportion for online shopping, sorry, it is incomplete, is same as the proportion of male. Okay, female proportion of online shopping is same as male proportion for online shopping. Means both are equally doing the online shopping, male and female. Suppose that we have to check. Then these two population proportion test we can test. Okay. In this case, P1 will be proportion of females and P2 will be proportion of males, like that. Then female are more fond of picnics than male. Okay, if we want to check this, again we can use this test. Youth spends more time on mobile than teenagers. Okay. Farmer suicides are less in Gujarat state than Maharashtra. Like this, we can use it in several ways or in several cases. Okay, all right. So here is the test statistic for two population proportion test. It is P1 minus P2 upon P into 1 minus P into 1 upon N1 plus 1 upon N2, right? Here P1 is the proportion of that particular characteristic from first group, okay? So P1 is X1 upon N1, where X1 is the number of successes in N1 independent trial, or your sample is of group 1 is N1. So out of that N1, how many are there meeting with the or are of the type of whatever the characteristic is under study. And P2 is X2 upon N2, that is X2 is the number of successes in N2 independent trials, or N2 is the sample size of your second group. Then this P value, this is computed as N1 into P1 plus N2 into P2 divided by N1 plus N2. Okay, I hope it is clear to everyone. Now the decision criteria is if reject H naught if mod Z is greater than equal to Z alpha by 2. Generally everywhere this decision criteria will be same, that reject the null hypothesis if your calculated value is greater than tabulated value. Okay, here some incomplete sentence is there. It should be reject H naught when this is true. All right. Now let's take actual example. In a random sample of 500 men from district A, 300 are found to be smokers, right? In 1000 men from another district B, 550 were smokers. Do the data indicate that two districts are significantly different with respect to prevalence of smoking among men, right? So first of all, we will formulate our hypothesis. So in words, if we want to formulate our hypothesis, how we will tell this hypothesis or construct this hypothesis? Anybody? It is given in symbols here. I want in words or in sentence. How we will construct this hypothesis? Yes. Respond.
Percentage of the smokers in both the city are equal.
Very good, Sandhya. You have given right answer. Okay. I will make it in more scientific language that there is no significant difference in the proportion of smokers in district A and district B. There is no significant difference. This is a statistical language we can say to formulate any hypothesis. Means what? Ultimately, in simple words, both are equally both are equal, both proportions are equal of men smokers in district A and district B, right? So that is P1 is equal to P2 against H1, P1 not equal to P2. Now I have already told you this is our test statistic. So what we need to compute this test statistic is value of P1, P2, P, N1, N2. What is N1, N2 from this? What are the values of N1 and N2?
N1 is 500, ma'am, and N2 is 1000.
Very good, Bhagyashri. So N1 is 500 and N2 is 1000. Very good. That is the sample size from both the districts. Okay. So you can see here N1 is 500, N2 is 1000. Again, some more figures are given here. 300 are found to be smokers. So from this, we can calculate the value of P1. So how we will calculate value of P1?
0.6.
P1 is 0.5, 0.55.
Okay. See, for P1, 300 are smokers and total are 500 samples are taken. So it will be 300 upon 500. And for district B, that is P2, when we calculate, it will be 550 divided by 1000. As Bhagyashri said correctly. Okay. So this we have. Now P, how P is computed? Same I have given here. Okay. Now P, how P is computed is N1 P1 plus N2 P2 upon N1 plus N2. Once we know these values, these are just the calculations, isn't it? So N1 is 500, P1 is 0.6 from here. Then plus N2 is 1000, P2 is 0.55 divided by, again N1 is 500 and N2 is 1000. So the value of P is 0.5667. If you compute this, you will get 0.5667. Okay. Now the computation of Z. It is P1 minus P2 means 500 minus 1000. Sorry, P1 is 0.6 and P2 is 0.55. So 0.6 minus 0.55 divided by P we have computed as 0.667 into 1 minus 0.667 into 1 upon N1 that is 500 plus 1 upon N2 that is 1000. So if you calculate this, you will get the value 1.8587. Now this is positive since it is 0.6 minus 0.55. But again, it can be negative also in some cases. No problem at all if you get the negative value. Now this is the value of table value of Z at alpha 5% level of significance. Again, it is 1.96. Now the decision, see the computed value of Z, it is 1.8587. It is less than 1.96, isn't it? Calculated value is 1.8, which is less than the table value 1.96. So we cannot reject the null hypothesis, or we have to accept the null hypothesis. Means what? The proportion of smokers in district A and B do not differ significantly, isn't it? In this way, how we can interpret our results. All right. Now the next test may be again of your interest, because I think your questionnaires are in the type of only that Likert scale, and more questions are like that. So it is a again important and useful test for your research. Okay. So let's see first the some requirements, how and where we can use this chi-square test for independence. So It is used to analyze frequencies of two variables with multiple categories. Okay. At least two variables we should have and minimum two categories for that variables we should have to determine whether the two variables are independent. So we have to, from the name itself, it is given here that it is the test for independence, when we have to say whether two variables are independent or not. Variables should be measured at ordinal or nominal level. Okay. Sometimes if you don't have ordinal or nominal level, isn't it? Ordinal means what? When order is important. Like when you give in Likert scale, no? It is like agreed, strongly agreed, then neutral, not agreed, and strongly disagreed. Okay. So this order is there, and that order is also important because it indicates the sentiments of that people towards that question, isn't it? So when the order is important, it is called ordinal variable. And nominal means what? Just for the sake of understanding or calculation purpose, we have given the some code to it. Then it is called as the nominal. For example, suppose we have given male as 0 and female as 1 to indicate that it is a data of male 0 and the data of female 1. It is a nominal because you can take vice versa also, that female as 1 and male as 0. It doesn't indicate any importance to the values. Okay, then we call it as a nominal data. Okay, so this is the difference between ordinal and nominal. For both types of data, you can use chi-square test of independence. And although suppose you have the data in continuous form, then you can make it in categories. Like suppose age groups are there, then divide your age groups like whatever, suppose it is some like teenagers or youth or senior citizens, right? Like that you can divide the according to the ages in particular categories. So that also can be done while using this chi-square test for independence. So again, let's see some examples so that whatever ideas are there, it will be clear to you that when we have to use this chi-square test for independence. So the first example is habit of cinema going and literacy are independent, right? Then time spent, it should be time spent on mobile and age groups are independent, isn't it? Just as I have said, you can whatever the age are there, you can differentiate it into categories, into different categories like 0 to 10, 10 to 15, because nowadays very small children, in fact infants also between 0 to 1, they are also using mobiles for different purposes, isn't it? So you can distinguish the age groups into different categories. Then intelligence and economic conditions are independent. Levels of education and marriage adjustment scores are independent. In every case, see, there are two variables. Like here, the habit of cinema going people and literacy, whatever is their literacy level, that you can check. And every variable, for every variable, we have to consider two or more than two categories. Like time spent on mobile, you have to categorize it like 1 hour, means less than 1 hour, 1 to 3 hours, 3 to 5 hours, 5 to 10 hours, and age group also. Again, you have to take different categories for age groups also. So for every variable, you have to consider minimum two categories. Like intelligence, very intelligent, intelligent, so very poor, like that you have to distinguish the characteristic intelligence into different categories. Same is the case for economic conditions. You can consider poor, then middle class, then rich, then very rich, isn't it? And you can check whether these categories are independent or not using this chi-square test for independence. Then levels of education, again you can take primary, then high school, then colleges or undergraduate, graduate, uh, sorry, postgraduate, then highly educated, like that you can take levels of education. And marriage adjustment scores. So depending on education, is the marriage adjustment score depends. So again you have to uh, categorize this into different categories, marriage adjustment score also. So in these cases, how we will formulate the hypothesis. Habit of cinema going and literacy are independent. See here, it is very important that your null hypothesis is in the form of independency. They are independent, and your alternate hypothesis will be dependent, because if you take here H naught as dependent, then your conclusions will be exactly in the opposite direction. Okay, they are completely wrong. Okay, reverse. So you should be very careful while formulating your null hypothesis. Again, second hypothesis is time spent on mobile and age group are independent. Against time spent on mobile and age group are dependent. Okay, now the test statistic. The test statistic is chi-square. This symbol is known as chi. So chi-square is equal to summation over I Fi minus Ei whole square upon Ei. Fi is the observed or experimental frequencies. Ei's are the expected frequencies. I will tell you also, taking one example, how we calculate these expected frequencies. Okay. Right now, you just see that this is the test statistics for chi-square test for independence. Then the decision criteria. Reject H naught if chi-square is greater than chi-square R minus 1, C minus 1 at alpha percent level of significance. Okay. This R is number of rows. C means number of columns of the contingency table. Okay. In the example, we will see how it is. And accept H naught if chi-square calculated, means whatever you will compute from this formula is less than or equal to chi-square R minus 1, C minus 1 at level of significance alpha. Okay, so let's see actual example. To find whether a certain vaccination prevents a certain disease or not, an experiment was conducted. The data collected is as follows, isn't it? There are so many vaccines for so many diseases. As corona, in corona period also we have seen everybody get vaccinated. Okay, so was it really useful? So if the study is like that, then we can use this chi-square test for independence. Okay, so here the status is taken as attacked by the disease. Okay, vaccinated and attacked by disease. How many people are there? Out of 800 are 148 such people are there, right? And those are not vaccinated and attacked by the disease, 572 are these people are there. From the sample size of 800, 572 are identified like this, that they are not vaccinated and attacked by the disease. 12 number of people are vaccinated and not attacked by the disease. And not vaccinated and not attacked by the disease are 68 are the number. Okay, so here in all we have 800 number of sample. Now how to find out the observed and expected frequency? Okay, so from this example I have taken these different classes according to what we have. These whatever is given or whatever we found in the sample, this is called as the observed frequencies. Okay, So these are the observed frequencies, and from these observed frequencies, we have to compute the expected frequencies. So let's see how we will compute this. So the expected frequency. Now the first class, okay, that is vaccinated and but attacked by the disease. Now from here you can see that vaccinated are there and attacked by this disease 148 are such number. So we have taken this 148. Now what we need is see this total of this row. This is called as the contingency table. Okay, these are number of rows. Sorry, these are number of rows. That is 2 rows are there and 2 columns are there. So R is 2 and C is 2. Right. Now attacked by the disease. This is the total, that is 720, and vaccinated people are there, that is 160. Okay. So see now this calculation. It is 720 into 160 divided by 800. That is 144. Okay. This is expected frequency, how we compute. Now, see the second class. It is vaccinated and not attacked by the disease. Okay. Remember this. Vaccinated and not attacked by the disease. Now see here, vaccinated and not attacked by disease. How many are there? 12. Okay. So this is your observed. How we will find out the expected frequency is corresponding to this 12. See the row total of that row in which that value is there. It is 80. So 80 into 160 divided by 800. Okay. Oh, I have not given the calculation here, but if you compute 80 into 160 divided by 800, you will get this value as 16. Okay. Now, the next class is not vaccinated, means this is the actual what we have, but this is the expected frequency, 12 and 16 here. Not vaccinated and attacked by the disease. Not vaccinated and attacked by disease means this is the value of observed, that is 572. Now anybody can tell me how we can find the expected frequency of this particular cell? Yes, anyone? How we will find the expected frequency corresponding to this cell of 572? It's simple. How we can compute this?
572 multiplied by 800 divided by 148.
No. See here, how we can calculate is, see this 570 is here, see its location, see the corresponding row total, see the corresponding column total, and then divide by the total number of observation. So 572 means what? Corresponding row total is 720. So 720 into 640 divided by 800. Right. In this way, we will compute this. Now, can anybody tell me how we can find out the expected frequency corresponding to not vaccinated and not attacked by the disease? That is corresponding to this cell. Yes.
80 divided.
It will be 80.
Multiplied by 640. Divided by 60. Divided by 800.
Very good. What is your name?
Smita Bagul.
Right. Right. Very good. So as she said correctly, we will find the expected frequency in this cell as 80 into 640 divided by 800. So in this way, we will complete this table, right? Now, once you have expected frequency, the next calculation, if you see our test statistic, it is what? Fi minus ER. What is Fi? Observed. That is already we have from our data, observed frequencies, isn't it? It is there. Then expected frequencies, we have to subtract from observed, do it square for every cell and divide by EI. So this is how we will compute here. So I have made here two columns, that is Fi minus EI. This is observed our Fi and expected frequency, that is EI. So Fi, that is 148 minus 144, so 4. Fi minus EI is 4. Next what we need is Fi minus EI square upon EI. So Fi minus EI is 4, its square is 16. So 16 divided by EI is 144. So if you compute this, I think something is wrong there, this value. So if you do it, you will get it. If you find it, you will get whatever the value is there. Okay, so 16 divided by 144. Whatever you got, you write down it here. I think it's wrong here, wrongly taken. Then next till again Fi, that is 16. For each cell we have to do the same. So 16 minus 12, that is minus 4. When we do it square, it will become plus 16 again and divided by EI. So 16 divided by 16. So it should be 1. Oh, I think all these are wrong values.
4 minus 16, na? Then square divided by 144.
No. Fi minus EI, its square, that is 16. And then divided by EI, that is again 16. So it should be 1 here.
Okay.
Again here, the difference is minus 4. So 4 minus 4 square, that is again 16 divided by 576. In that way, sorry, I'm really sorry, I have not checked this, but all these are wrong values. Okay. So we have to find the values like this. Again, 16 divided by 64. So it should be 0.25, not 2.5, but it will become 0.25. So like this, we have to check. Now, suppose I don't know really because I have to check it again. So suppose that the chi-square value, how the test statistic we will calculate is just sum of this last column, that is 13.89. Again, I will say suppose that it is true, that it is 13.95. It is nothing but your test statistic. Then come the parts of the decision criteria. So again, you have to reject H0 if chi-square, means this value of calculated value of chi-square is greater than chi-square R minus 1, C minus 1 at level of significance alpha, right? Now, since we have 2 rows and 2 columns, R is 2, C is also 2. So that is 2 minus 1 is 1, 2 minus 1 is 1. So chi-square with 1 degree of freedom and the level of significance 5%, that is 0.05. This value is 3.841. Now decision reject H0 if chi-square, that is 13.89 is greater than 3.845. Yes, 13.89 is greater than 3.845. So we have to reject the null hypothesis. Means what? Attack of disease and vaccination are dependent, because your null hypothesis is they are independent and we are rejecting it, right? And that's why we can say that there is sufficient evidence to reject the null hypothesis. Means we can say that the proportion is that they are not independent, means they are dependent, like this. Okay, I hope you understood this. Yes, this is the values of chi-square table, how we see this. For example, here we have 1 degree of freedom and at alpha level 0.05. So you can see 1 degree of freedom and the corresponding value of 0.05 here. So it is 3.845. Okay. So in this way, we will get the table value to take the decision. And of course, as I have said you in the last lecture, that nowadays software gives the p-value, right? So again, the criteria will be same. If your calculated value is greater than alpha, that is 0.05, then we have to accept the null hypothesis. And if it is less than 0.05, then you have to if p-value is less than 0.05, then we have to reject the null hypothesis. The decision is taken like that. All right. Now the next test is chi-square test for goodness of fit. Okay. Previously, means just before some time, we have seen the proportion test for two samples. Okay. Now suppose you have to check the proportions for more than two samples or two populations. Then we can use this goodness of fit test. Okay. It is again a non-parametric test, right? It is used to determine whether the distribution of cases in a single categorical variable follows a known or hypothesized distribution. Means the proportion is same. That is what we are testing. Okay. Of course, for more than two groups, if we want to check. So let's see one example. A chemical extraction plant processes seawater to collect sodium chloride and magnesium. This is from science stream example. Okay, but we will discuss some example from your stream also, no problem. A chemical extraction plant processes seawater to collect sodium chloride and magnesium. It is known that seawater contains sodium chloride, magnesium, and other elements in the ratio of 62:4:34. A sample means if total 100 observations are there, from that 62 are corresponding to first category, 4 are corresponding to second category, and 34 are corresponding to third category. We are taking example of three proportions or three groups. A sample of 200 tons of seawater has resulted in 130 tons. Means total 200 tons of seawater was taken and extracted sodium chloride and magnesium from that, and the proportion of that is we are checking whether it is really in the proportion of 62:4:35. 130 tons of sodium chloride, 6 tons of magnesium, and of course the other elements are remaining one, that is 136, means 64, isn't it? Again 64 are the other elements. So are these data consistent with the known composition of seawater at 5% level of significance, right? This is known from previous experience that it should be in this ratio, and actually we have considered the 200 tons of seawater and extracted sodium chloride, magnesium, and other elements, and we are testing whether they are really in this proportion or not. Right? Let's see another example. Or I will be happy if you can give some example of this type from your stream. Yes. Any example? When we have some pre-assumed values, okay, or proportions, and now by taking sample, we are checking whether it is really like that or not. That is what is the case where we can use this chi-square goodness of fit test. Yes, anyone? Nowadays, means some few days back, there was a very hot issue, isn't it? That is of the Marathwada reservation in Maharashtra. So all that is based on the categories, isn't it? Different categories that are made according to caste, right? Means whatever the sorry, proportion is there of reservation, right? It should be according to that categories. For example, OBC is there, SCs are there, STs are there, and whatever the proportion is there, and actual proportion means given proportion in reservation and actual proportion. If we want to check whether they are same or not, then yes, we can apply this chi-square goodness of fit test there. Okay, like this. I hope the example is very clear to you that how we can check it. Now, of course, the variable under study should be categorical, that is qualitative, and it can be of dichotomous type, that is binary or nominal or ordinal. Any type of data you can consider under this. Of course, the observation should be independent. Then the groups of the categorical variable must be mutually exclusive. Means what? Every whatever the sample is there, it should belong to only one category, not more than one category. Okay, that is what is the requirement. There must be at least 5 expected frequencies in each group of your categorical variable. Means for all cells, the number should be greater than 5. For all types, there should be more than 5 observations. That is what is the requirement. If you see the test statistic, it is same as the previous one, that is summation fi minus ei square upon ei. Okay, then the decision criteria is reject h naught if chi-square is greater than chi-square with n minus 1 degrees of freedom. Okay, previously it was r minus 1, c minus 1. Now it is total number of observations minus 1 at level of significance alpha. And we have to accept h naught if chi-square is less than equal to chi-square with n minus 1 degrees of freedom at level of significance alpha. All right. So the same example I have taken, and we will see whether it gets accepted or not. Means really the proportion of whatever the sample we have, it is in this style, that is 62:4:34. Right? Now, here how we compute it. Observed and expected frequencies. For sodium chloride, what is observed from 200 tons, 130 ton was found sodium chloride. Okay. Now, how we find the expected frequencies is, now 62 is there. Say, sodium chloride, if 100 tons are there, then sodium chloride is expected to be 62 tons. That's why here we have considered 62 tons here. Okay. But we have 200 tons, so multiply by 200. That is total of all. Or from here, total 200. So multiply by 200. Then divide by 100. Whatever is there, it is the expected frequency. Right? Or from, it is clear now. If in 100 it is 62, from 200 it must be 124. That is double of this, 124. Right? Then for magnesium, if in 100 terms magnesium should be 4, then in 200 terms it should be 8. Right? It's double like that. So 4 into 200 divided by 100, that is 8. Again, for other elements expected to be 64 in, what we found is 64 in 200 tons, right? And actually it should be how much? 34 in 100 tons. So this expected frequency we will compute as 34 into 200 divided by 100, that is nothing but 68. Now again we will find out the observed frequency minus expected frequency, that is 134 minus 124, that is 6. Then 6 minus 8, that is minus 2. 64 minus 68, that is minus 4. Again we have to compute this, that is Fi minus Ei square upon Ei. Fi minus Ei is 6, so 36 divided by 124. Now yes, this column is correct. Then minus 2 square, that is 4 divided by 8, so it is 0.5. Now here it is minus 4 square, that is 16 divided by 68, that is 0.23, right? Now our test statistic is, you can see here, this is summation of fi minus ei square upon ei. And already in last column we have computed that, so it will be just sum of this column, that is 1.02. Okay. Now, this test statistic is 1.02, and the decision criteria, already we have seen that we have to reject H naught if chi-square, means this calculated value of chi-square is greater than chi-square with n minus 1 degrees of freedom. So, we have only observation of 3, so it will be 3 minus 1, so that is 2, and 0.05, and this is the level of significance. If you see the chi-square table at 2 and 0.05, it will be 5.99. Now the decision, so what will be the decision? Yes, anyone? Yes, what will be the decision?
The composition of seawater.
Yes, Smita.
एक मिनिट 1 मिनट हाँ.
Everything is given here. You have to just see and take the decision according to this. No one?
The composition of seawater is greater than the level of significance.
So no, it is less than. See this calculated value, it is 1.02, which is less than the table value. Table value is 5.99. So this is less value. So we have to accept the motha असेल. If your value of chi-square, that is 1.02, is greater than this table value, then you have to reject. But in our case, this is not true. Okay, your chi-square value, that is 1.02, is less than 5.99. So we have to accept our H naught. Okay, so we have to accept H naught. Means what? Accept H naught means, yes, whatever the proportion is given, that is 62:4:34. That is the correct proportion of sodium chloride, magnesium, and other elements in the seawater. Okay, that is how we will interpret. Here it is given. All right. Okay. So this is about the chi-square test of independence. Now we will see some non-parametric tests. All right. Is the PPT visible?
No, ma'am.
No. Okay. Now,
Yes, ma'am. Now it is visible.
means it is different PPT than the first one. It is in brown background. It is there, na? Introduction slide is first one. Ranks and median. What are non-parametric tests? Is it visible?
Yes, ma'am.
Okay, very good. Thank you. All right. Now, first of all, I would like to tell you why we should go for non-parametric tests. Okay. See, parametric test means what? First of all, your data should be continuous for all parametric tests. Which are the parametric tests? The t-test we have seen in the last lecture, that are the parametric tests. ANOVA, one-way, two-way, that are the parametric tests. F-test, that is a parametric test. Okay, all these are the parametric tests. Chi-square comes in both parametric as well as non-parametric. It is the only test which is both type. It is in parametric test also it is there, and non-parametric also it is there. All right. Now, why one should go for non-parametric test? Because in parametric test your data should be continuous. Right? Continuous means what? Some measurements are there, like height is there, weight is there, then yield in turns in is there, like this, or the income is there. If directly, see, if the income is given in numbers, like suppose 20 lakh, 20.5 lakh, or 1.5 lakh, like that, then it becomes continuous data. If your data is like that, you can use the parametric test. Again, one requirement of parametric test is your data should be normal. Okay. If data is not normal, then you have to go for non-parametric test. Again, if your data is in categories or Likert scale, then you have to go for non-parametric test, because your data is not continuous in that case. So you should go for non-parametric test in such cases. Okay. Or your data is skewed, then also you have to go for the non-parametric test. I think already Kaveh sir has covered this, all skewness, central of tendency, all these things. Okay. How we can check normality and all that. Okay, so I will not go in that details, but if you want to see how is the skewed distribution, it is like this. Huh? This is a positively skewed distribution. Means initially it is greater and afterwards it is going on a lower side. So it is not normal. In normal, what we have initially lower, then a maximum part is in middle part, and then again it is lower down. So like that, normal distribution is there. Okay. Right. Now, as we have seen in parametric test, we use summation xi minus x bar, that is the variance type. Variance is there in every test. But when we go for non-parametric test, usually it based on ranks or median. For parametric test, we consider mean. For non-parametric test, generally we consider the median. Okay, that is what is. I think already you know what is the median. Okay, but let me tell in 1 minute what is the rank and what is the median by one example. So I have taken one example here. So it is, suppose your observations are like this. Then if we want to find out its rank, the lowest one will have the first rank, highest ones, next lowest, that is the, or next maximum will have second rank, next maximum will have third rank, fourth, like here. This is the smallest, so rank 1. Then next one is the 2, 3, 4, 5. Now after 5, this is next maximum number. So its rank is 6. After 7, 13 is there, so its rank is 7. Like that, we have to give the ranks, right? Then the median, I think already you have studied this. What is the median? The median is the value of which 50% of the observations are below that value and 50% of the observations are above that value. Okay. Then if the data is ranked in order, it is the middle value. If symmetric distributions, the mean and median are same. In skewed distribution, median is more appropriate, right? So these are, so what is the median in this case? Anybody knows? Already I think you have lecture on this. So what is the median of this data?
5.5.
5.5.
6. Okay.
6.
5.5, ma'am.
6, ma'am.
Okay.
6, ma'am. First.
5.5.
Where
In
it's good
second,
that so many students are responding. Okay, but let me clear one thing. Median is not the value of rank. It is not value of rank. It is the value of observation. ती ऑब्झर्वेशन असतं ते असं ऑब्झर्वेशन तुमचं जे तुमच्या डेटाला 2 इक्वल पार्ट्स मध्ये डिवाइड करतं. लेस दॅन दॅट सेम व्हॅल्यूज, लेस अप्पर दॅन दॅट और मोर दॅन दॅट सेम व्हॅल्यूज. बघा आता इथे तुम्ही जे उत्तर दिले ते तुम्ही बरोबर दिले, पण कशाच्या संदर्भात दिले? तुम्ही रँकच्या संदर्भात दिले. रँक नसते ती, व्हॅल्यू असते ती. त्या रँकच्या करस्पॉन्डिंग ही जी व्हॅल्यू आहे ना तुमची ऍक्च्युअल डेटा मधली, ती मेडियन असते. ओके, सो फॉर एक्झाम्पल जर इथे 10 च्या ऐवजी सपोज 11 ऑब्झर्वेशन असते, राईट? जेव्हा 11 ऑब्झर्वेशन असतात तेव्हा 11 प्लस 1/2 म्हणजे 6 ऑब्झर्वेशन. येस, 11 प्लस 1/2 म्हणजे 6th ऑब्झर्वेशन तुमची मेडियन येईल. 6 नाही येणार मेडियन. 6th ऑब्झर्वेशन जे काही असेल दॅट इज द मेडियन. जसं 6th ऑब्झर्वेशन म्हणजे 7 आहे. ओके, हे झालं इन केस ऑफ ऑड नंबर्स. ऑड नंबरची मेडियन अशी फाइंड आउट केली जाते. बट इन केस ऑफ द इव्हन नंबर्स, हाऊ वी फाइंड मेडियन? इव्हन असेल नंबर तर जसं आता हा 10 नंबर आहे, आपले टोटल नंबर ऑफ ऑब्झर्वेशन 10 आहे. That is an even number. So for this, we will compute the median as 10/2. That is the 5th observation plus 10/2 plus first observation. म्हणजे काय? 5th observation plus 6th observation यांचा ऍव्हरेज घ्यायचा. सो इथे 5th observation काय आहे? 5 आहे. 6th observation काय आहे? 7 आहे. So average of these two observations means 5 plus 7, that is 12, divided by 2, that is 6. So 6 is the median for this. Got it? Somebody I think has told that 6 is the median. Yes.
Yes, ma'am. I am also calculate like this, ma'am.
Okay, very good then. So that 6 is the median of this data. Okay. Right. I should also understand who is giving the answer. Okay, so in this case we find out the medians. All right, now here one example again I have taken to find out median. Now please tell me what is the median in this case?
140.
140.
140.
So fast, Smita, then
140. 140, ma'am.
Savita. Very good.
140.
140.
Very good. So now see here. Yes, the median is 140. Now for the next example, what is the median?
2.5, ma'am.
2.5.
Mm.
I think Purnima has said 2.5.
Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
So she said correctly, the median should be 2.5. Right.
Thank
Again, since 10 observations are there, then 5th observation, that is 2, and 6th observation, that is 3. So 3 plus 2 is 5, divided by 2, that is 2.5. 2.5 is the median for. Very good. Right. Now let's see the actual example. Okay.
Mm.
So first is the sign test. Now, when to use sign test? So in examples like this, suppose an analyst for a hotel asks 7 people to rate a new recipe of cake, right? On a 5-point Likert scale. Got the example, I hope. For 1 means what? That the cake is really terrible, not good at all. And 5 is it is excellent, right? Means in this is a Likert scale example. So 1 is terrible, 2 must be good, then 3 must be okay. 4 must be very good, and 5 is excellent. Like this, the scales are given. Now 7 people has given their responses like this. First one said that not good. Terrible means very bad. Okay. Then 2 is not good. So first one has given his response as 2. Second, whoever is there, that person has given it as very excellent, isn't it? Then next one has given 3. Then next one has given 4, 1, 4, and 5. See, in case of parametric test, we test u is equal to mu 0. That is mean. We take. Roll number 7, please mute yourself. All right. Then we have this example, right? And what we have to test now, there we compare the mean, here we have to check the median. See what we have to test at the level of significance 0.05. Is there evidence that the median rating is less than 3? This is what we have to check. Median rating is less than 3. There we have mu, suppose less than 3. In parametric, in non-parametric, we have median is less than 3. So what is our hypothesis here? Anybody?
I think 4 is the median, so it is less than 3. No, it is more than 3.
Not 4, but since it is given, what we have to test, some specified value of median we want to test, right? That is the average, not average, the median of the group is less than 3. Means what? Many people don't like this test. Less than 3 means what? Don't like this test. Current 4, 5 excellent play. Means we are checking whether people don't like this cake. In short, if we want to say, that is what we have to check. So let's see here. So here again, how we will formulate our hypothesis, what will be the test statistics. So let's see one by one. Eta, that is median. You can use any notation here, or you can write down median, no problem. Median is equal to 3 against H1. Median is less than 3, isn't it? It is given here in the last slide that check whether the median rating is less than 3. That is what we have to test. So this is the hypothesis. Then alpha, it is given as 0.05 in the example itself, it is given. Now, this is the test statistic. What is the test statistic here? It is the number which is less than median is the test statistic here. So number of people who are saying that it is not good, or 1, 2, less than 3. So only 2 people are saying that it is not good, 1 and 2. These are the 2 indicated in white numbers, isn't it? Only 2 people saying are that it is not good. So hence our test statistic here is S is equal to 2. Now how we will find the table value for this? Okay. Since our value of test statistic is 2, we will find the value that probability of X greater than equal to 2. And where we will see this value of P, we will see in the binomial table. Okay. There are tables called binomial tables. I have given here. Yes, these are the binomial table. You can find it in Google, internet, no problem. In 1 minute, you will get this table. Now, see our example. What we have? In total, we have 7 observations. So our N is 7, right? Then, which probability we have to find is X greater than equal to 2. Since total probability is 1, we can also find it as 1 minus exactly opposite of this, that is X less than equal to 1. Okay, or X less than 2 means what? X less than equal to 1. म्हणजे 0 आणि 1 दोनच व्हॅल्यू असतात. Discrete distribution, it is based on binomial distribution which has discrete values 0, 1, 2 like this. Okay, up to n. So फ्रॉम दिस बायनॉमियल टेबल. आता बघा आपला हा इकडे दिलेला आहे 7, दॅट इज व्हॅल्यूज ऑफ n, इट इज गिवन हिअर. आणि इथे व्हॅल्यूज ऑफ x आहे. आता आपल्याला x काय पाहिजे, लेस दॅन इक्वल टू 2 हवाय, सॉरी ग्रेटर दॅन इक्वल टू 2 हवाय. ओके, म्हणजेच काय करणार तुम्ही ह्या टेबल वरून x ग्रेटर दॅन 2 पाहिजे तुम्हाला. आपला अगेन व्हॉट यू हॅव इज this value p. You have to see success rate as 0.5. So here greater than equal to 2 म्हणजे काय, पहिल्या दोन व्हॅल्यू सोडून द्या, 0.08 आणि 0.05. उरलेल्या सगळ्या प्रोबॅबिलिटीजची ऍडिशन करा किंवा 1 मायनस ह्या दोन प्रोबॅबिलिटीजची ऍडिशन घ्या. दॅट इज 1 मायनस 0.08 आणि मायनस 0.0055. इफ यू ऍड दिस टू इट इज 0.063, isn't it? So 1 minus 0.063, that is 0.937. In this way you can find this value. Okay, then the decision will be as usual. Do not reject h naught if, केव्हा आपण रिजेक्ट करतो, when your test statistic, that is 2, is greater than 0.937. okay, 9 येतो, it is less, the value of test statistic is less than your table value, that is 0.937. so you have to accept h naught, or there is no sufficient evidence to reject h naught, so you have to accept h naught. In this way you will interpret your result. Is it clear? This is the sign test, non-parametric test. I hope it is clear to you. There are many tests also, and easily it can be done in SPSS. Okay, but I think the time is over, so let's stop here.
I think no queries, ma'am.
So
I-
if anybody has any question from your thesis that you are doing nowadays, what your research is going on, please feel free to ask me. Okay, do you have any questions? That day also I forgot to ask if anybody has any questions. So thanks Radhika that you have reminded. Any question? You can write down in chat box, or you can directly ask me by unmuting yourself.
I
No
think no questions, ma'am.
Okay then, no problem.
Okay, then I would like to conclude this session as Chaya ma'am explained well with different examples. It's very beneficial, ma'am, and thank you for having here. Thank you, ma'am.
Thank you, thank you.
Thank you, madam. Sonar madam.
Thank you, madam.
There will be a break for 15 minutes. We will rejoin again by 11:45.
Okay, ma'am.
Okay, ma'am. Okay.
Okay, ma'am.
Thank you. Thank you, madam.
Thank you, ma'am. Thank you, ma'am.